These are of it as it's positive, not as it's negative. It's supposed to be less than or equal to 0.
All right, I said,
it should be less.
I think these are, like I said, these are complicated because I think your first instinct is let's just multiply, get rid of fractions. But then that's going to get rid of some of your answers. So you can't do that. We didn't do one that was probably quite this complex yesterday, but we did one that at least started this way. What do I need to do with at least one of these? I'm going to move this one over the other side and get one side to be 0. So I get x minus 1 over x plus 1 is minus x plus 2 over x minus 3 less than or equal to 0. And so now I simplify these or combine these. You got to get a common denominator. What's your common denominator going to be? X plus 1 and then x minus 3 has to have them both. So this one is missing the x minus 3. I have to add it on top and bottom. This one needs the x plus 1. So I'll have x minus 1. This is going to be acting up all period, I think. X plus 1. All right, this will be x. Add in x minus 3. Add in x minus 3. Minus. Okay, I got this x minus 3. Oh, jeez. This x plus 2. So what do I add to both of those? X plus 1. And we want to see where that is less than or equal to 0. The numerator, or excuse me, the denominator, you really don't need to multiply out. You can leave it like that because in the end, we want to see where the denominator equals 0. We're going to get a common denominator of x plus 1 times x minus 3. But I have to FOIL the numerator and subtract all that. I got to simplify it as far down as I can. So you got a FOIL here. I got a FOIL here. Okay, so when I FOIL, that's going to give me x squared. Negative 3x, negative x is minus 4x. Negative times a negative is positive 3. All right, minus. Okay, and you got to keep that whole thing in parentheses. So when I subtract, I get x squared plus x plus 2x is plus 3x. 2 times 1 is plus 2. All this has to be less than or equal to 0. All right, when you distribute that negative, what am I left with on top? Okay, you'll get a negative x squared. That'll add up to, oh, geez. Not working. Try it again. There we go. That'll add up to 0, right? Negative 4x minus 3x looks like I get negative 7x. 3 minus 2 plus 1 over x plus 1, x minus 3 less than or equal to 0. All right, now at this point, what makes the numerator 0? What makes the denominator 0? Okay, those are critical points or break points. Negative 7x plus 1 equals 0. That gives me negative 7x, so it's going to be positive 1, 7. And then what do I get for the denominators? I get negative 1, and then I get x equals positive 3. All right, those are my critical points. Number line here, 0. And now negative 1, it really doesn't matter where you put this stuff as long as it's in the correct spot. So negative 1, we'll put way over here. Can it equal negative 1? Can it equal negative 1 and be part of the solution? No, because it's in the denominator. It'll make it be undefined. So I'm going to put an open circle there. Can it equal 1/7? This is 1/7. It can because that's the numerator. And 3. Put this over here. Can it equal 3? Nope. Now I just need a test point. X equals negative 3. X equals 0. That's a 0. X equals 1. And then x equals 5 for those. And I'm going to plug it into here and just see what my signs are. Let's start with -3. Negative 7 times -3 is 21 plus 1, positive value. -3 plus 1, negative. -3 minus 3, negative. So in the end, that whole thing's going to be what? Positive, because a negative times a negative is positive. All right, now, I do believe this one alternates. Can anybody confirm?
Mm-hmm.
Yep.
All right, so same thing. You would use your test points, but you need to get this pattern here. And now we want it less than or equal to 0, which will be from -1, not including -1, to 1/7 union 3 to infinity. Okay, for that.
So why is it not negative infinity to -1?
This piece here?
Yeah.
All right. Do you agree that it comes back positive?
Yeah.
So that means we're looking for all the x values that will be less than or equal to 0. So anything that comes back positive will have to be bigger than 0. Okay, so like this one here, that is, if I plug in -3, that gives me 22 over, what is that? -3 minus 1 is -2 times -5. That's 10, right? So that's like 2.2. 2.2 is not less than or equal to 0. So, and then anything else will also be bigger than that. So all I have to do is a positive or negative. Anything negative will satisfy less than. Anything positive will not satisfy. So I'm just checking the signs. Okay, for that. All right. Anything else? I knew number 119 was hard, but anything before that? Okay. All right. I'm going to reiterate what I always reiterate. Take the time, because I know a lot of you just snap a picture of the homework and you never check your answers. And I think it shows up on tests. Okay, if you don't take the time to figure out, A, do you have it in the right form? Like, if you answered it correctly, like sometimes you leave, because when I look at your answers online, like it might be an interval notation and you get something not even close. So take the time, is it correct? And is it in the right form? So that way, if it's not in the right form, you can fix it. Like maybe it's Descartes' rule of sign, it should say 2 or 0 positive zeros, and you actually answered it. All right, so I'm seeing a lot more of that as the year progresses because I don't think you're taking that time to actually check it. And like I said, I think it shows up on tests because you assume what you're doing is correct, but it may not be. So again, take the time, look at your answers, and then if they're not right, ask questions or come in and see me. You're allowed to do that. All right, everything else good? All right, we're going to go chapter 4. Okay, we're going to start a little exponentials, little logarithms. Okay, first of all, we got to do some exponential. Logarithms you probably touched upon a little bit last year. Got any notes for you? Oh,
Thanks.
all right. Exponential functions. We got to do this, and then this will lead into logarithms. Okay, what is that? Not as long of a chapter. All right, first thing there, just the definition, exponential functions. Take a constant to a power. Okay, you see that at the top there. A couple key things, though. A cannot, A has to be greater than 0, which means it can't be negative. And then A cannot equal 1, or for those cases. So you cannot take a negative number to that power. Now here's some exponential functions. Now I just said you can't take a negative number to the power, but why is the second one okay? Really, what's the only thing being taken to the power? The 4. There's a negative in front of it, but it's not being to the power. What you can't do, this does not qualify as an exponential function. Did anybody see the issue with that? Okay, it's not continuous. What happens when you plug in 2? What do you do? Andy?
It will be 16.
And what happens when you plug in? So what were you going to say? Were you just going to
negative something? So it'll be like,
yeah. So what happens when you plug in 3? What do we get? Negative. What happens when we plug in 4?
positive.
Negative. So it's not, like I said, it's not continuous in terms of that. So this has to be a positive value, okay, for them. Now you can put a negative in front of it. That's fine. Now you can also multiply. All right, big question here. 5 times 3 to the x. Can I write that as, can I just say that's the same as 15 to the x? Is that equivalent? No, not equivalent. Has to do with the order of operations. What do you got to do first? Multiplication or exponents? Exponents. So if you plug in the number 2, if x equals 2, okay, 3 squared is 9. 9 times 5 is 45. So f of x equals 45. Let me call that g of x. What does g of x equal? What's 15 to the second power? 225. So g of x would be 225. And if it was true, they'd have to be the same. So you cannot do that. You got to keep that constant out in front. You can have decimals, 0.8 to the x plus 4. You can have fractions, 1/2 to a power. Okay, but you just can't have a negative number in there, and you can't have 1 as well. All right, let's graph this. You're going to need to know this graph. This is going to be a base graph. We're going to go through it now, but you're going to have to, I don't know if saying memorize is the right word, but you're going to have to know it. Let's just go old-fashioned here and do -2, -1, 0, 1, and 2. And then plug those in. I'm going to spread this out a little bit. So on my screen, I'm going to go every 2 lines is 1 for my scale. It might help for yours. So 1, 2, 3. -1, -2, -3. All right, just be careful. What's 2 to the -2 power?
4.
Not 4?
1, 4.
That's better. That's probably what you said first. 1/4. Make sure it's 1/4. Okay. 4 that. All right, 2 to the negative first. 1/2. 2 to the 0. Anything to the 0 power is always.
0.
Oh, Matthew, you didn't
Oh,
just say
1,
that.
1, 1, 1, 1, 1, 1.
Whoa, what's going on?
Yep, 1.
It is 1. Anything to the 0 power is 1. 2 to the first power is 2. 2 squared, 4. All right, now plot that. -2, 1/4. -1, 1/2. 0, +1. 1, +2. 2, +4. All right, is it linear? No, it's not linear. What happens as we get further to the left? As I plug in -3, as I plug in -4, as I plug in -5?
It approaches 0.
It approaches 0. Okay, so I'm going to graph this. Make sure you put arrows on it. It's going to get big real quick. Okay, you start plugging in 3, 4, 5, 2 to the 5th, 2 to the 6th, 2 to the 7th. It gets big real fast. Domain. Is there anything we can't plug in? Everything works, right? You plug in 0, you get back an answer. You plug in a negative number, you get back an answer. Your domain is all real numbers. Range. What's our range? Just run double check here. Okay. 0 to infinity. Does it include 0? Nope. 0 to infinity. All right. In behavior, as x approaches infinity, what about f of x? Justin. As x approaches infinity, what does f of x do? Approaches infinity. All right, we'll stick with you, Justin. As x approaches negative infinity, what does f of x do? Goes to 0. So it approaches 0. All right. It does not have to go to negative infinity or positive infinity. Some people had that misconception in first period. Goes to 0. All right, so that is 2 to the x power. Okay, 2 to the x. All right, what about 1? All right, you cannot use a negative number. It doesn't count as an exponential function. You can't plug in a negative to a power. But if you do a fraction to a power, something between 0 and 1, it doesn't look exactly the same. So let's take a look at 1/2 to the x power. Going to do the same thing. I'm going to do -2, -1, 0, 1, and 2. All right, 1/2 to the -2. If you remember our exponent rules, if you have a fraction to a negative power, remember what you can do with the fraction? You can flip it and make it positive. So this becomes 2 over 1 to the second power, which is going to be 4. All right, fill in the rest. All right, give me 1 second. All right. Brooke, what do you got for your rest? For the rest?
I got 2, 1, 1/2, and 4.
Good. So we got 4, 2, 1, 1/2, 1/4. I'm going to do the same thing. Make it a little bit easier to graph. Go every 2 marks. My scale will be 1. And I got -1, -2. I go 1, 2, 3, 4. 1, 2, 3, -4. All right, so -2, 4 will be up here. -1, 2, 0, 1, 1/2, 2 1/4. Okay, same idea except it starts on the left, positive, and then it goes through and it goes towards 0. Domain and range. Domain, all real numbers. I can plug everything in. Negative infinity to infinity. Range, 0 to infinity. All right, what about your end behaviors? X goes to infinity. F of x is going to 0. And as x goes to negative infinity, f of x is going to positive infinity. Okay, so we got our end behavior, we got our domain and range. All right, this is your basis for exponential function. The number bigger than 1, whoops. Okay, it's going to go and increase from left to right. Number between 0 and 1, it's going to decrease from left to right. All right, evaluating exponential functions. I want you to be able to do a lot of these without your calculator. You can use the calculator to check it. This first one's straightforward. Second one, you just got to be careful. All you're doing is you're plugging in here 4. F of 4 equals 3 times 4 minus 2. So it's 3 squared. F of 4 equals 9. All right, second one here, plug it in -2. Keep your answer as a reduced fraction. Don't use your calculator. See what you come up with. G of -2 equals -2 times 10 to the -2nd. All right, Anna, what do you got? Final answer.
-1/50.
-1/50. Okay, I agree with that. So you got 10 to the -2nd power. One thing you need to be able to take that and make it a fraction. So it's going to be 1/10 squared, which is going to be -2 times 1/100. And then that will reduce to -1/50. All right, so be able to do most of these. I mean, there's going to be some where you need your calculator, I know that, but most of these you should be able to figure out without. All right, a little bit of simplifying here. All right, 5 square root of 3 times 5 square root of 3. That simplifies to 5 to a power. Now just remember, x cubed times x to the 4th. Aiden, you remember what that is? X to the what?
7.
7. We add them. Same thing here. Instead of an x, we got a 5. What's square root of 3 plus square root of 3? That's a good question. Okay, that is just 2 square root of 3. Okay, so if you get something like that, you make it 2 square root of 3. That would be that case. Now, don't write this down yet because I want to flip A and B, or B and C. All right, now go ahead and write down B. All right, 5 radical 2 to the radical 5 power. What do you do to a power to a power? Multiply. Okay, so remember, if you have x squared, we'll make this something a little simpler. To the 5th power, you make that x to the 10th power. Well, this is going to be 5 to the square root of 2 times square root of 5, square root of 10 power. Okay, for that. Now, you always want to try to reduce, but radical 10 doesn't reduce. We're just going to leave that. All right, now write down that third one. This one gets a little messy. All right, so if you see this as a division, what we want to do is write it as a fraction. So I'm going to make this 4, 3 radical 2 over 8 square root of 2. All right, the final answer is 2, 3 radical 2. That's our final answer. How do we get that? Okay. First issue we got is if you're simplifying things, they have to have the same base. We do not have the same base. We got a 4, we got an 8. So remember, if you got 4 squared over 8 cubed, you cannot take 2 minus 3. You cannot subtract those. We will use that fact, though. You know, if you got x to the 8th over x cubed, you do subtract. But we got to get the same base. How do I get the same base? Andrew?
Oh.
Is that a hand? Or just a stretch?
It's just a stretch.
Too bad now.
Review. I don't know.
All right, how do we get the same base? Matthew?
Take out a 2 from the bottom.
Take out a 2? But then you got stuck with that 2 there. All right, you're on the right track. 4 and 8 can both be written as 2 to a power. 4 is 2 to what power? 2 squared. Make 4 2 squared. Okay, and you still have this 3 radical 2 on the outside. Make 8 2 cubed. And we still get that radical 2 on the outside. So what we want to do is we want to manipulate our base. Say, all right, can I write them as the same power? And we can here. 4 is 2 squared is 8 is 2 cubed. Now using the property from B, what do you do with the powers? You multiply them. And remember, when you multiply things with radicals, you can only multiply the numbers quote on the outside together. So this would be 2 times 3. This would be 6 radical 2. And then this one would be 2 to the 3 radical 2. And what I get, once I get to that point, what do you do to the exponents? Subtract them. Okay, so that's where we get the 3 radical 2. Okay, for that. Get rid of that. So you got to be careful there on the simplifying. Okay. Find the exponential function of the form f of x equals c times a to the x that contains the points 0, 4, and 332. All right, so get that down. Take a second to think about this. All right, what we want to do is we have to find A and C. And once we find those, our final answer needs to look something like f of x equals 5 times 3 to the x. So when we're done, okay, that's what we're looking for. So you got to find A, you got to find C. And this is all we got. Take that form, and we got 2 points. Plug one of the points in. Which point would be better to plug in? 0, 4. All right, plug it in. So into f of x, plug it into just the general form. F of x equals c times a to the x. In one of these cases, like sometimes you don't know what's going to happen. You just got to try it, see what happens. So I plug this in. 4 is your f of x. That's what my answer is. I don't know what c is. I don't know what a is, but I do know x is 0. A to the 0. Anything the 0 power is? 1. So what am I left with? C is equal to 4. I found C. Once I know C, I can now plug it into the equation. Okay, it's going to be 4 forever. So now I got f of x equals 4 times a to the x. All right, still need to find what x or a is. Use your other point. So plug in 332. Okay, so plug that in. And now 32 goes here. 4 times a cubed. Now you may be able, because some of these are not, you're not dealing with decimals or anything too like small or too big. You might be able to think about it and figure it out. But if you go through the steps, divide by 4, and I get 8 equals a cubed. You can either take the cube root, or you're going to say, all right, what to the 3rd power equals 8? It would be 2. Final answer now, f of x equals, what would we say, 4 times 2 to the x power. All right, flip that over. Transformations. We're going to have to do transformations with exponentials. All right, the first one is our base function. So I'm going to call this f of x equals 2 to the x. So over here, this is f of x equals 2 to the x. All right, what do I do to that function to get that second one? All right, it's a reflection across the y-axis. All right, so you see where it says g of x equals at the top? All right, so what do I do to the first one to get that next one? Do you remember? terms of transformations.
2 to the negative x?
2 to the negative x. Yep, we put a negative with the x. So that would be 2 to the negative x. Okay, for that. All right, that next one. Again, f of x equals 2 to the x. I believe I have h of x for that one, don't I? All right, so h of x is a reflection over the x-axis. All right. Anthony, what do I do with that?
Make the whole thing negative.
Make the whole thing negative. Put a negative in front of it. So negative 2 to the x. All right, now I just got the dotted line there as a reference. What's really going on with the two functions? The blue one is your 2 to the x. What's happening with the green and the red? They're just being shifted which way? Left or right. Okay, shifted left or right. So f of x equals 2 to the x. So for the red one, the one on the right, I'll call that g of x. I don't know, do I have anything listed for it? No? All right, I'll call it g of x. G of x. All right, watch where you put that. So we get 2, if we shift it to the right, we actually do what?
Subtract by 2.
Subtract 2. Now, where do I put that minus 2 at? With the x. So it will be part of the power. So it will be 2 to the x minus 2. The green one, I'll call that h of x. That will be 2 to the x plus 2 because it's been shifted left. And that last one, okay, again, that's dotted line as a reference. That one's been moved what? Down 3. So to shift it down 3, I'll call that g of x. You subtract 3 from the whole thing. So make sure it's clear that that x is an exponent and that minus 3 is not with the x. It is down below, minus 3. All right, so just be careful on that. All right, we'll end it there. We'll finish this up on Monday. No homework. Two-day test, you could have day off. Appreciate it.
Many thanks.
Oh, yeah. I looked at it. It's hard. It's very hard. It's gonna be the hardest. Yeah, I'm gonna get it and be like, yo, listen. You're not. The radius of a roundabout is 12 meters. So how fast? Yeah. How fast can you go with the friction coefficient of 0.2 to the